Hello everybody. This is a lesson on how to create a histogram. This lesson goes with topic 1, section 2 of the textbook. Um, so here's the example I'm going to use right here. This example is in your book right here. Let me show you in the book where it's at. So here is topic 1 right here, section 1.2 histograms. And it's a few pages in. Actually, it's the second page in, right here. It says example. Here is the exam grades of 15 students, 88, 48, 60, etc., etc. Now, it's explained in the book, but I think it requires a little bit more explanation than what's in the book here. So that's why I'm making this video. And this is a very important topic. I'd hate for someone to not to understand what's going on. So here's the our 15 students, and here's their test scores right here. The first thing you have to do is you have to scan the data and look at the highest and lowest scores. So the highest score is 97. The best student in the class got a 97 on the test, and the lowest score it looks like is 48, right there. All right, so let's make this a little bit thicker here. So step 1 is you scan the data. Okay, and then step 2 is you have to decide what the bins are going to be. In some books they call them bins. In other books they call them classes. Groupings would be another name for this. So just decide how big there's how we're going to organize our data. So the scores range from 48 to 97. So let's group this by tens. So let's take all the scores from let's check how they do it in the example. So that's the same. Okay, yeah. So they also group by 10, starting at 40. So I'm going to group together everything from 40 to 49.99. All right, that's my first bin. And then I'm going to group together everything from 50 to 59.99. In other words, everything in the 50s. And then 60 to 69.99. 70 to 79.99, 80 to 89.99, and then my last bin will be 90 to 99.99. All right, let's make some lines here. Okay, and then I just start counting. And so my first number, 88, I'm going to cross them out as I go to make sure I don't forget anything. 88 goes in this bin. 88 is in the 80s, so put a little tally mark there. 48 goes here in the 40s. 60 is exactly 60, so that would go here in the third group. 51 goes here. 57, that's also in the 50s. Put another tally mark there. 85 goes there. 69 is in the 60s, 75 is in the 70s, 97 is there, 72 is in the 70s, 71 also in the 70s, 79, 65, 63, and finally 73. Now, when I get to the fifth mark, I'll just go diagonal so I can more easily keep track if I have a lot of data. And so that tells me I've got, let's make another column here. Okay, so my next column will just be what we call the frequency. Okay, so in the 40s, there's one student who scored in the 40s. 2 students who scored in the 50s, 4 students scored in the 60s, 5 students scored in the 70s, 2 students scored in the 80s, and then 1 student scored in the 90s. So this table right here, this table I just made, this has a special name. This is called a frequency table. Also, it's known as a frequency distribution as well. The distribution means how are the test scores, these students' test scores right here, how are those test scores being distributed across the spectrum? And so you can see they're ranging from 40s down to almost to 100. Okay, now for the histogram. So I need some clean space here. I'm going to make some space here. Just a second here. Okay, I'll make my histogram right here. So histogram is a visual display of a frequency distribution like I just made. You need, back to my marker here. So you need an x-axis. The x-axis is always the values of the variable. In this case, 40s to 90s. And just make a mark wherever the bins are, that's how you designate your x-axis. So I'm scaling by tens because I grouped by tens. So 60, 70, 80, 90, 100. Okay, and that's the x-axis. The y-axis is the frequency. And that is, the highest frequency is 5, so I'll just go by ones. 1, 2, 3, 4, 5. Okay, and then you make a bar, and each bar is as tall as the frequency is. So the first group, 40 to 49.99, has one student, so you make a bar, and the bar goes from 40 to 50, like that. And then the next two students scored in the 50s, so you make a bar in the 50s area. You make a bar that's 2 units high. And then the next group in the 60s right here, you make a bar that's 4 units high. So the height of each bar tells you the frequency of each of these bins. And then in the 70s, there's 5 students, so you make a bar that's 5 units high. And then in the 80s, I've got 2. In the 90s, I've got 1. All right, so that's the basic idea of histogram. Let's go to the textbook. You'll see a nice cleaned up version of what I just did. Here's the frequency table. It's the scores. Notice the square bracket means you're including 40, and the round bracket means you're not including 50. And there's one student who scored between 40 from 40 up to 50, 2 students from 50 up to 60, which is what I counted. And then here is a nice clean version of the histogram right here. Let's go back to the histogram that I made, my sloppy histogram. There's a lot of advantages to a histogram. This data set only had 15 students, but imagine you had 1,000 students and you had a histogram of your 1,000 students. It would be really hard to establish trends by looking at the raw data of 1,000 students, but if you have a histogram of 1,000 students, you can instantly see a lot of trends. So for example, on this one, it's only 15 students, but the trends are pretty apparent. I can see that most of my students scored here in the middle in the 60s and 70s. The entire range ranges from the 40s up to 100s. But only a few down here in the 40s, only one in the 40s, and only one student scored in the 90s. I can also tell that by the heights, the number of students in each group as well. And so it's a nice visual way to show the distribution of the test scores in this case. Histograms were probably the most commonly used way to describe a distribution of a quantitative variable. And that is it for this lesson. So now when you go back to the textbook, read through the example and look at the distribution, and then you can answer the questions about it. And then the next page will go on to how you can describe the histograms. But that's fairly self-explanatory So this page you can just read it on your own. That's it. Have a good day.